Hello everyone, my name is Adran Ali, the Bazooka Prophet, and today we're working on a very interesting video talking about the calculations that are involved in the relationship between mole and Avogadro's number. Now, before I enter this question to solve it, we first of all understand the formula that connects them together. But first of all, we should understand that a mole is the quantity of atom that is being contained, and we should understand that one mole of a substance, one mole of a substance, one mole of a substance contains Avogadro's constant, which is 6.02 times 10 raised to power what now? 23 atoms per mole. Now look at it. The particles here can either be an atoms, molecules, or an ion. Now, not to waste time, the formula is number of moles N is equal to Np over 6.02 times 10 raised to the power 23, whereby N simply means the number of moles and Np simply means the number of particles, and this is your Avogadro's constant. Then any question that has to involve atoms, like how many atoms are in, how many molecules are in, just know that Avogadro's constant has to be applied. Now we should also recall that your N, you can recall that N is equal to mass over what now? Molar mass. So we can as well as say that anywhere I see N, I put this. So it can be mass over molar mass is equal to number of particles over 6.02 times 10 raised to what 23. Now the question now fall back here now. How many atoms are in 16.3 grams of sulfur? Given to us in the question. How many atoms? Meaning I am looking for my MP question mark. I was given the mass. The mass here is 16.3 gram, and that the molar mass of sulfur, of course, is 32.07 given to you in gram per mole being convert, and that your Na here, which is your Avogadro's constant, is what you are, which is atoms per mole. Now, from this formula, we'll make our Np the subject of the formula. So by saying so, because our Np is equal to, I can multiply, by having mass multiplied by 6.02 times 10 raised to the power 23 all over the molar mass. My mass here is 16.3 times the molar mass here that I have here all over, this is Avogadro's constant, the molar mass here is 32. And when you do the multiplication and you divide, then it will just be 3.006 times 10 raised to the power what now? 23 atoms of sulfur. So we'll move to the next question. So we'll move straight away to the second question that says how many carbon atoms are in 0.0022 gram of CO2. Now, this question is very simple. Now, look at it. Chemistry has a unique format, and that format is you understanding the rudiment and understand how a particular question is solved, and how that question can be applied to other questions that you have to solve. Now, they have told you how many carbon atoms, meaning your number of particles, is what they are asking you for, are in 0.022 grams of CO2. Now it means you are looking for the number of atoms of carbon in this compound or molecule, which is CO2. Now look at it, very simple. So the formula is shortcut. I don't want to solve it in the long processes so that you will not be shortcut. Now, the formula is solution. Number of particle Mp is equal to the mass of the compound is Mc, the mass of the compound, multiplied by the number of atoms of the carbon. It can be any element in a particular compound. Just take note. Multiplied by 6.02 times 10 raised to power 23 over the Avogadro, okay, over the molar mass of the compound. The molar mass, capital letter M, the molar mass of the compound. So let's solve together. Now, what is the mass of the compound there? It's what, class? It's 0.022. So here become 0.0022 multiplied by how many atoms are there, or how many atoms of carbon are there in the compound. How many atoms there is one? Carbon here is one, oxygen here is two, so it's one. So I put here one multiplied by the Avogadro's constant times 10^23 over the molar mass of CO2. Very, very simple. Look at it. Molar mass of CO2. Carbon is 12. You are aware from here. Oxygen is 16 multiplied by 2. That gives us 44 gram per mole. So that becomes 44. When you multiply this and this and this over, the final answer should give me 3.01 times 10 raised to power what now? 19 atoms of carbon. Very simple. So let's move quickly to the next question. So we'll move to the next questions saying how many hydrogen atoms are present in 25.6 gram of urea, given that the molar mass of urea is 60.06 gram. Now this question is very simple. It is similar to the one that we solved for how many carbon atoms are the same. So we just move straight to the formula by saying the MP is the number of particles of the hydrogen atoms equal to what is the mass of the compound, which is urea. It is 25.6 multiplied by how many atoms of hydrogen do we have in this compound? Sorry, this is urea. Is it not 4? We have 2 here. This is 2 hydrogen atoms times this 2 in the bracket, which is 2 multiplied by 2 will give you 4, multiplied by the molar mass of times the Avogadro's number, and that the molar mass has been given to us to be 60.06. Now, when you multiply, the final answer you should get should be 1.03 times 10 raised to power 24 atoms of hydrogen. Now, in the next question I will drop, that will be for you. So when you solve it, if you are correct, I also drop the answer too. So we'll move to the last one that I said that you're going to solve, and very, very easy. The question says, how many hydrogen atoms are in 72.5 gram of isopropanol, which is C3H8O, which is the molecular formula here, giving to you the molar mass. This question is similar to the one that we saw before, whereby you say the number of particles is equal to the mass of the compound multiplied by the number of hydrogen in that compound times the Avogadro's constant over the molar mass. And with that will give us the final answer. For now, finally, please, when you are done solving this question, do well to drop your procedures in which you use in solving this question for me. Drop it on my comment section, and I owe you something. God bless you.